Welcome to Section 1 of our Java SE21 Developer Preparation course. This lesson covers some of the most critical foundational topics you will face both on the certification exam and in real-world Java development. We are going to break down primitive data types, string handling, loops, control flow, and the latest Java 21 pattern matching features. I will be explaining these concepts in a simple, practical way. Stay with me until the end of this section, because I'll be sharing common traps that Oracle loves to put on the exam, along with strategies to write better code. Also, don't forget to grab the free PDF study guide linked in the video description. Let's jump in and start building that rock-solid Java foundation. Let's start with a real-world banking application. If you are calculating daily interest rates, you cannot afford to lose any fractional data. While standard primitive types like float and double are great for general decimals, they introduce floating point rounding errors. For exact mathematical precision, especially with money, you must use the Big Telby class. Understanding when to graduate from primitives to Big Telby is a critical distinction that is tested frequently. Imagine you are writing a script that reads temperature sensor data, and it needs to run continuously until a shutdown signal is received. Because you need to take an initial reading before you can check if it's a shutdown signal, you should use a do-while loop. This specific loop structure guarantees that your code block will execute exactly once before the Boolean condition is ever evaluated at the bottom. String manipulation is a huge part of Java. Suppose you are processing a massive list of user inputs and need to combine first and last names together inside a loop. Because strings in Java are immutable, meaning they cannot be changed once created, using the standard plus operator inside a loop creates a massive amount of wasted objects in memory. Instead, the best practice is to use a string builder object, which allows you to efficiently append text without wasting memory resources. Next, let's look at the new pattern matching features in Java code. 21. If you have a method that receives a generic object and you need to perform different actions based on whether it is a string, an integer, or a custom class, you no longer need cluttered if-else chains and explicit casting. You can now use a pattern matching switch statement. This allows you to test the object's type and assign it to a variable directly within the case label, making your application flow incredibly clean and readable. Consider a scenario where you are writing a parser to read a configuration file line by line. If that file happens to be completely empty, your parsing logic should never even start. The safest control flow choice here is a standard while loop. Because a while loop evaluates its condition at the very top, before any code inside runs, an empty file will immediately return false. The loop body is safely bypassed, preventing potential runtime errors. Here is a very common trap on the certification exam: primitive type promotion. If you are calculating screen coordinates and you multiply a byte variable by a short variable, what happens? In Java, whenever you perform arithmetic on smaller integer types like byte, short, or char, the compiler automatically promotes those values to an int before doing the math. Always remember that the result of these operations is an int, unless you explicitly cast it back down. If you are debugging a legacy Java application and notice that multiple cases in a switch statement are executing back-to-back when only one was intended, you are witnessing fall-through. In traditional Java switch statements, execution will automatically fall through to the next case unless you explicitly stop it using a break statement. Forgetting this break keyword is a frequent source of logic bugs and a highly tested concept. Let's talk about variable scope. If you declare a local integer variable inside a method, say, to count active user sessions, you cannot use or print that variable until you assign a value to it. Unlike instance variables at the class level, which get default values automatically, local variables must be explicitly initialized. If you try to use an uninitialized local variable, the compiler will catch it and refuse to build your application. Memory management is another key topic. If you create a customer object and assign it to a variable named client1, and then you assign client1 to a new variable called client2, you haven't created a second customer. You simply have two references pointing to the exact same object in the heap memory space. Because they point to the same location, modifying the customer's data using client2 means that change is immediately visible to client1. When building an authentication module, you'll need to compare a user-entered password against a string in your database. You should never use the double equals operator for this. The double equals operator only checks if two references point to the same memory location. To safely and accurately check if two strings contain the exact same sequence of characters, you must always use the dot equals method. If you need to extract a specific portion of text, like grabbing the middle 5 characters of a product code, you will use the dot subsquare method. By providing a starting index and an optional ending index, this method generates a brand new string containing only your targeted characters. Just remember, string indexes in Java always start at 0. When interfacing with lower-level hardware, you might need to define integers using different numeral systems. Java makes this easy with specific prefixes. To write a binary literal, you start the number with 0b. If you need a hexadecimal value, you prefix it with 0x. Recognizing these specific prefixes is essential for reading code quickly on the exam. Imagine you are searching through thousands of records. Once you find the exact target you are looking for, there is absolutely no reason to keep looping. To optimize your code, you should use the break keyword. When Java encounters a break statement inside a loop, it immediately destroys the loop entirely and moves on to the next section of your program, saving valuable processing power. Alternatively, what if you are processing a list of employees and you just want to skip over the inactive ones but keep processing everyone else? For this, you use the continue statement. Unlike break, which kills the loop entirely, continue simply halts the current iteration and jumps straight to the next cycle. It is the perfect tool for filtering out unwanted data on the fly. Writing multi-line SQL queries or JSON payloads inside Java used to mean dealing with messy string concatenation and confusing escape characters. Now, you can use text blocks. By wrapping your string in 3 double quotes, Java automatically preserves all your line breaks and indentation. It makes complex strings infinitely easier to write, read, and maintain. You are guaranteed to see questions testing variable naming conventions. In Java, variable names must begin with a letter, a $, or an underscore. They absolutely cannot start with a number, they cannot contain hyphens, and you cannot use reserved keywords like public or class. Knowing these strict rules will save you from giving away easy points on the exam. When you need to iterate entirely through a collection, like an array of server names, the enhanced for loop or for each loop is your best friend. Instead of manually tracking an index counter, you cleanly define a temporary variable of the matching type, add a colon, and then provide the array name. Java handles the entire iteration process for you automatically under the hood. For our final technical concept, let's look at modern switch expressions. If you want to assign a discount code based on a customer tier, you can now use a switch to yield a value directly to a variable in a single step. By using the arrow operator, instead of a traditional colon, Java automatically prevents that messy fall-through behavior we talked about earlier, making your code significantly safer and much more concise. Congratulations on completing this first section. I highly encourage you to apply these concepts immediately by completing the attached practice test. Active coding and working through scenarios is the absolute best way to improve your memory retention and build the critical thinking skills required to pass. A full practice test is included with this lesson to help gauge your progress. Take a short break, and I will see you in the next section where we will conquer object-oriented programming.